All right, so continuing with example 4AI, we already said that the answer is no, that 48 degrees cannot be um, it cannot be the size of each exterior angle of a regular polygon, and the basic reason is that um, because when 48 degree is an exterior angle, n is equal to 7.5, but n, um, which is what? N is equal to 7.5, which is not an element of the set of natural number. So to begin with, in order for 48, in order for any angle to be an exterior angle of a regular polygon, n, which is the number of sides, must be a whole number. It must be a natural number. If it is not a natural number, for example, if it is a decimal or a fraction, then the answer is no. If it comes out to be a whole number, then the answer would be yes. All right, so now let us look at why would I say if one exterior angle is 24 degrees, the sum of the exterior angles would be 24n would be equal to 360 degrees. All right. Let's try and see if we can explain why the 24n. If I have let us say 5 angles and they're all, let's say, 24 plus 24 plus 24 plus 24. 1, 2, 3, 1, 2, 3, 4 plus 24. Now, the shortcut for adding 24 5 times is simply to multiply what? 24 by what? By 5. All right. So let us say there were 5 exterior angles and each of them is 24 degrees. I could find the sum by simply multiplying what? 24 by 5. The shortcut for adding 24 5 times is to multiply 24 by 5. Now, in like manner, but there are not 5 sides, there are a total of what? Of n sides. Now, the shortcut for adding 24 n times is to multiply 24 by what? By n, where n here is the number of sides. So 24n is equal to 360. Divide both sides by 24. So therefore, n would be equal to 15 sides. So the answer here would be yes. Yes, 24 can be the size of an exterior angle. And this is because when one exterior angle is equal to 24 degrees, n, um, n is equal to 15 sides, and n is an element of the set of natural numbers. So if n comes out to be a natural number, and that is 1, 2, 3, well, it can't be 2 or 3. N has to start from 3 because remember, a polygon must have 3 or more sides. So if n is a natural number greater than or equal to 3, then yes, the exterior angle can be that size. If n is not a natural number, then the answer would be no. All right, let's have a look at B. Why is it impossible for 21 to be the size of one exterior angle for a regular polygon? For a similar reason, we could say let n, which is the number of sides, let the number of sides be n, let the number of sides be n, which is an element of the set of natural numbers. All right, so so if one exterior angle is 21, the sum of the interior angles would be 21n, and the sum of the exterior angles of all polygons is 360 degrees. So that I'll say that again. If one exterior angle is 21 degrees, the sum of the exterior angles of the n exterior angles would be 21n, and the sum of the exterior angles of all polygons is 360 degrees. So we divide both sides by what? Not by n, by 21. Divide both sides by 21, and we would get n is equal to 360 divided by 21. N is equal to approximately 17.1. All right. So therefore, 21 degrees cannot be an exterior angle of a regular polygon, because when one exterior angle is equal to 21 degrees, n is equal to 17.1, and n here is not an element of the set of what? Natural number. Therefore, it is impossible for 21 degrees to be the size of one exterior angle for a regular polygon. When you do the calculation for n, you must get a natural number, which is what? Greater than or equal to 3. If you get a decimal, the answer is no. All right. If you get a decimal, if you get a rational number or an irrational number, the answer is no. Well, if you get a rational number, the answer is no. All right. C says each exterior angle of a regular polygon is 18 degrees. How many sides does this polygon have? All right. So if each exterior angle is 18 degrees, I could say let n be the number of sides, which is the same as the number of exterior angles. So the sum of the exterior angles would be 18n is equal to 360 degrees. Divide both sides by 18, and I would get n is equal to 20 sides. All right. All right, that's one way you could have looked at it. Again, you could also maybe approach it from a formula approach that n, the number of sides, is equal to 360 degrees divided by one exterior angle. So n would be equal to 360 degrees over 18. N would be equal to 20 sides. All right, so that's the end of the examples. Please go over them. Please try and analyze it based on how I analyze it. If you're having difficulty with analysis, for now, just try to use the formulas that I gave you earlier. However, it would be really good if you try and fully understand it. In our next class, we can look at these questions again to see if you're understanding to ensure that you're understanding that you understand it fully. All right, that your understanding is up to par, that you understand it fully, understand fully what I'm saying. All right. It is the reasoning is, in my opinion, not very difficult. However, um, I do suspect that there are students who will have what trouble with the reasoning. All right, and we can look at ironing out those issues in the next class.